Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to familiarize ourselves with the EaselJS drawing API and how we manage the stage, groups, and the basics of animation. We don't need to go into too much detail, as we've already covered the basics of Canvas drawing in the Canvas Essentials course. If you want to refresh your memory, you can check out lessons 2.1 through to 2.3, which takes you through the Canvas basics and more or less all of the drawing API. So let's get started. Open up the project folder that we created last lesson in Sublime. You can just drag it onto the Sublime text icon. You'll also want to open up the same icon on the terminal. So we should have our terminal open to Tuts Canvas, and we can type in grunt to start our project. Now if we navigate to localhost 9001, you'll see our project. Here it says app started. So to start off with, we're going to have a quick look at how modules work. If you remember from the last lesson, we set up Browserify, which is used to manage our dependencies and to tie up all of our modules into a single file, with each module having its own private scope. I always code in strict mode, as it helps you out in debugging. Strict mode, for example, will notice if you have an undeclared variable, and it will throw, whereas non-strict mode will just ignore it and declare it as a global. Now the first thing we need to do when we're using EaselJS is to make sure we wait for the DOM to be ready. We could attach a function to the onLoad event, but this would wait until absolutely every asset is loaded, including pictures, whereas we just need to know that the DOM is ready to be accessed. Now is the perfect time to create a module to help us out with that functionality. If I create a new folder in lib called utils, and in here I'm going to create an index file. Module.exports is what we want this file to expose to other modules that are requiring it. We're going to create a function called DOM_ready. We'll create it in a separate file and require that into this module, like so. We don't have to put JS at the end, that part is assumed. If I save this as index.js, I can now go and create our DOM_ready module. Create a new file, we'll save it as DOM_ready, and in here I'm going to put a little helper function that works out when the DOM is ready. You see, it's not just as simple as listening to a DOM_ready event. We have to listen to ready state change, and when ready state change is complete, we'll call this function callback. But the DOM may already be ready when we call DOM_ready, so we also have to check before we do anything if DOM is already ready. That's a bit of a mouthful, but it's a lot more convenient like this than writing it every time. So we're exporting the DOM_ready function, save it here. It's being imported here into the utils where we can put many other tools as well. And from our main file, we can include it. We'll start by including utils. When you have index as a file inside a folder, you can include that without even writing the word index. So this is the same as including it like this. Now we can include DOM_ready by referencing utils like this. Another thing we're going to be doing a lot of is typing create.js. Create.js is the namespace that has all of our Canvas functionality. So I'm just going to create an alias here, var c equals create.js. To make sure that's worked, we'll console log game started, and we'll console log the EaselJS version, c.easeljs.version. The web page is already refreshed, and you can see it's working here. So let's get drawing. We'll use our DOM_ready function, and we'll start by setting up our stage. Stage equals a new create.js stage, and we pass in the ID of our canvas, which is main. So let's start by drawing a circle. We'll go and create var circle equals new c.shape. We'll need to access the graphics property that each shape has. Circle.graphics.beginFill, green, so we're beginning a fill which is green in color, and then we go .drawCircle. Notice this syntax of chaining together commands. If you remember, in native Canvas API, we have to put all of these commands one after the other, and it can become quite cumbersome. Each of these methods returns the graphics object back so that we can chain them all together. Now we can simply set the circle's X and Y position, and we'll add it to the stage. If I save that, and you'll see that we don't see anything. This is because we haven't updated the stage. You can set up as many commands and shapes and objects as you like, but nothing will actually happen until you update the stage. If I call stage.update, you can see our circle. Now let's draw a square. You'll see the code is pretty much the same, except we use draw rectangle and pass in a width and height rather than just a radius. And you can see our square here. What if we want to group these two together? If you want to create layers in your game, as you most certainly will, such as a layer for the background elements, a layer for the foreground, a layer perhaps for your interface that goes over the top of the game, then you're going to need to group them together. For that we have the container class. It works just like the other classes. We can give it an X and Y position and add it to the stage. But now, instead of adding the circle to the stage, we can add it to the group. So if I add it to the group instead of the stage, when we refresh, you'll see it's disappeared. This is because it's gone off screen, because our X and Y position of our container are further to the right. Let's make our canvas a little bigger. We'll start by creating a CSS folder inside our app folder. We'll create a new file and drop in the following CSS. We've just set up a background color for our body, and we've given our main canvas some positioning to center it and a fixed width and height. We'll save this as main CSS. Next, we need to add a task to our grunt file to copy those CSS files over to our build folder. It's pretty similar to our other tasks, but the source that we're moving is app/css/main CSS, and we're moving it to a build CSS folder. While we're here, let's set up an image folder and a task to move any images we later put into the project. So this other copy task will be called images, and this time we're not going to flatten the structure. We want our images to stay in the same structure. So our destination is build image, and we'll set a current working directory to app/image/ so that our source, instead of being an array of files, can just be any folders and any files that are inside images. Now if we restart our grunt task, you'll see that our main CSS has been put into the CSS folder. It hasn't created an image folder because we don't currently have any images. Back in our HTML file, we can add a reference to the style sheet, and we'll add the width and height to the canvas element as well. Now when I refresh, you can see our square and our circle. Remember, our circle has been added to the group. Let's add the square to the group as well, so you can see everybody's on the same coordinate system. Now, rather than calling stage update just once, let's have a look at the ticker class for animation. Really, it's not just animation that the ticker class is used for. It's basically your game's heartbeat. The tick event will get fired on the stage, and then will propagate down to any of the stage's children on every frame update. So we'll start off by going to the create.js ticker, and we'll set its timing mode. As a default, the ticker will use set timeout, but if you're in any sort of modern browser, you can use request animation frame, which is a lot smoother and more efficient with CPU usage. So we'll set it to the constant RAF, we'll set the frames per second to 60, and now we'll set an event listener on it. Ticker.addEventListener tick, and we can have a function that gets an event. On each tick we'll call stage update. Now stage update does two things. The first is it redraws all of the shapes and all of its children, but more importantly than that, before it redraws them, it will also fire the tick event on any object that is listening for it. This means we can encapsulate behavior of our child objects on an object-by-object basis. For example, I can set on our group an event listener for the tick event. When I use the on subscription rather than add event listener, the context of our handler here will be the object, the group. So I can set this.rotation equals this.rotation minus 1. So let's see what happens. You can see our group is rotating and taking our objects with it, but it's not really rotating around the center. I can change the group's registration point, meaning its center, by using regx and reg-y, setting them to 100 each. If I refresh that now, you'll see that our group is rotating around this center point here. So just to recap, we listen out for the tick event on the ticker static class, and each time we call stage update. Update will then go through all of its children and the entire tree hierarchy, and on each child it will fire the tick event before redrawing any shapes and containers. You can even pass arguments through the update, and they'll come through as event.params in an arguments array. To avoid having to remember which argument number I should use, I always pass in an object, so I can refer to my parameters like this, or this. So obviously there's a lot more to the drawing API than that. We can also draw text by setting a font and color, and using line width we can even constrain the line wrapping, and a shape needn't be a single object either. We can string together a long list of commands to create more complex objects that sit together. Here I've added a Bezier curve to our green square. Well, that's all for this lesson. Check back in for the next lesson where we're going to start to look at the structure of our application and how we can start coding in an object-oriented fashion to better organize our application, make the code reusable and modular. Ciao!